This is for Year 12 methods. It comes out of chapter 4 and it's about altering composite functions or altering the domain of the inside function so that the composite function exists. So to the question, if f of g of x does not exist because the range of g doesn't fit into the domain of f, how can I restrict the domain of g so that the composite function does exist? I'll demonstrate it with two examples of composite functions that does not exist and how we can alter the domain so that it then does exist. First example comes from g of f of x equals log base e 3x plus 1. So in this particular case, my inside function is f, so f of x equals 3x plus 1. And my outside function is g, and g of x equals log base e of x. The domain of f is all real numbers, because it's a linear. The range of f is all real numbers. The domain of g is 0 to infinity, non-inclusive of either, because it's a logarithm, and you can't put a negative or 0 inside of a logarithm. And the range of g is all real numbers. Okay, that doesn't fit into that, therefore the function does not exist. The range of f is not a subset or equal to the domain of g, because R is not a subset of 0 to infinity. It's too big, therefore the function does not exist. How can I change the domain of f? How can I change the x's that go in through f so that when they come out of f and have to go through g, it will fit? For that to occur, then my range of f has to be exactly equal to the domain of g. So the range of f has to equal 0 to infinity, remembering that f of x equals 3x plus 1. And if I was to graph 3x plus 1, it goes through there at 1 and goes through there at negative 1/3. Unrestricted, the range of f is all real numbers. I want the range of f to be 0 to infinity. To enable me to have a range of f that's 0 to infinity, the domain of f has to be all of these numbers, so the domain of f has to equal negative 1/3 to infinity, non-inclusive of the negative 1/3. So if the domain of f was negative 1/3 to infinity, then the range of f would be 0 to infinity, and then 0 to infinity would fit inside the domain of g. So to the question, what change do I need to make to the domain of the function f so that g of f of x exists, then g of f of x will exist if the domain of f was reduced to negative 1/3 to infinity. That is, make the domain of f such that the range of f then fits into the domain of g. A second example of how we can alter the function so that the composite exists. Let's take h of m of x, which equals 1 on the sine of x. So I've got m of x, which equals sine of x, that's my inside function, and I've got h of x, which equals 1 on x. So there's my composite functions. The domain of m is all real numbers. The range of m is negative 1 to 1, since it's a trigonometric function, the sine function. The domain of h is all real numbers except for 0, and the range of h is also all real numbers except for 0. I have a problem. My problem is that this does not fit into that because this range contains some zeros and the zeros are excluded from the domain of h. Therefore, h of m of x does not exist because the range of m is not a subset or equal to the domain of h, because -1 to 1 does not fit inside of all real numbers except for 0. How could I change the domain of m, that is the numbers that go into m, so that the range fitted into the domain of h? Well, I need to get rid of those zeros. So, what x values makes sine of x equals 0? And once I know what those x values are, I need to get rid of them. So here is my sine function. There are my zeros at 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, minus pi, etc, etc, etc. So the x values that make this equal to 0 are x equals n pi, where n is an element of all integers. So what domain do I want for m? The domain of m has to be all real numbers except all of the n pi's, because then the range of m will be -1 to 1 except 0. And now that will fit inside of the domain of h, because that's all real numbers except for 0. Therefore, h of m of x exists.